Hello students, now I am going to discuss Cambridge O-level chemistry May-June 2022 paper 21. May-June 2022 paper 21. Now I am going to discuss with you. Let's move. Number 1, here there are some compounds here. You know this name: ammonium chloride, barium sulfate, potassium iodide, potassium sulfite, SO3, magnesium nitrate, sodium ethanoate. This is the sodium salt of carboxylic acid, sodium carbonate, sodium phosphate, zinc sulfate. Now these compounds may be used once or more than once or not at all. One time or two time or not at all. You can use this compound's name formula. Now state which compound A reacts with dilute nitric acid to form a gas that turns lime water milky. You know, carbon dioxide gas turns lime water milky. So sodium carbonate, if you add nitric acid, salt plus carbon dioxide plus water is formed. Carbon dioxide turns lime water milky. So the answer will be sodium carbonate. To any carbonate salt, if you add acid, salt plus carbon dioxide plus water is produced. Carbon dioxide, if you pass carbon dioxide through lime water turns milky. B reacts with warm aqueous sodium hydroxide to produce gas that turns damp red litmus paper blue. You know, alkaline gas, ammonia gas turns damp red litmus paper to blue. So any ammonium compound, ammonium chloride is a ammonium compound. If you add sodium hydroxide, I mean any alkali, salt plus ammonia plus water will be produced. Ammonia gas. This ammonia gas is alkaline gas, so it turns damp red litmus paper to blue. Now number C reacts with dilute hydrochloric acid to give a gas that decolorizes acidified potassium manganate 7 KMnO4, potassium manganate 7 or potassium permanganate. You know, sulfur dioxide gas turns potassium manganate 7 from purple to colorless, and sulfur dioxide gas produced from any sulfite salt K2SO3. This is a sulfite salt. So if you add hydrochloric acid to any sulfite salt, if you add hydrochloric acid, sulfur dioxide gas is produced, which decolorizes acidified potassium manganate 7. Now D is prepared using a precipitation reaction. You know, barium sulfate is a white solid, so this is white solid, means this is precipitate means solid, so barium sulfate is insoluble in water. That's why barium sulfate can be prepared by precipitation reaction. E contains an anion, means negative ion, with a charge of -3. You know, phosphate ion, PO4 -3. This -3 phosphate ion. Formula of phosphate ion. This is the sodium phosphate. F is used to test for an oxidizing agent. Potassium iodide solution is colorless. If you add any oxidizing agent, iodine will be produced. So aqueous iodine is purple. Oxidizing agent oxidizes potassium iodide to iodine. Iodine is a brown solution, and potassium iodide aqueous salt solution is colorless. So if you add oxidizing agent to potassium iodide, observation will be colorless solution turns to brown. This is the brown. Iodine solution is brown color. So by this test you can test for an oxidizing agent. Now next, number 2, here some nitrogen, phosphorus, arsenic, antimony, bismuth element, their electronic configuration, melting point and boiling point is given. Now first state the electronic configuration for phosphorus. You know, phosphorus 15 2 8 5. First shell contains 2 electrons, second shell 8, 10, and third shell contains 5 electrons, 2, 8, 5. Now B, explain why it is easier to predict the boiling point of bismuth than to predict its melting point. You see, boiling point -196 gradually increases. That means boiling point increases. So boiling point has a trend. It has a regular trend, increases, but melting point increases, again decreases. So it has no regular trend. That's why determining boiling point is easier compared to melting point. Number C, use information from the table to explain why antimony is a liquid at 1000 degrees centigrade. You see, antimony melting point antimony melting point 630 degree centigrade and boiling point 1380. So 1000 degree centigrade is between these two values, so that's why this is a liquid. Or you can write melting point is below 1000 degree centigrade and boiling point is above 1000 degree centigrade, or 1000 degree centigrade is between the melting point and boiling point. If one temperature is between the melting point and boiling point, that compound will be liquid. Now the nitrogen, you know, dot and cross diagram, nitrogen triple bond, nitrogen triple bond. Any single bond contains 2 electron, double bond 4, triple bond 6. So 6 electron will be share. Here 6 electron share when 3 bonds are formed. Now nitrogen is a group 5 element, 1, 2, 3. 3 electron gives share, remaining 2 electron left. Nitrogen is a group 5 element, so it has 5 electron in its outer shell. This nitrogen also 2 cross electron. This is the dot and cross diagram for nitrogen. Number 2, explain in terms of structure and bonding why nitrogen has a low melting point. Low melting point means there are weak intermolecular force. There is weak intermolecular force which is easier to break, or you can write there are weak intermolecular force between nitrogen molecules, so which is easier to break. Number E, bismuth is a metal. Predict 2 physical properties of bismuth. Physical properties. This is number 1, conducts electricity, conduct heat, or you can write malleable, ductile, sonorous, lustrous. Sonorous means make sound, lustrous means shiny. Now this is calculation. Calculate the volume in dm cube of 92.2 gram of nitrogen at room temperature and pressure. Now nitrogen mass is given, so we will apply solid formula. Moles of nitrogen mass divided by molar mass of nitrogen. Nitrogen is 2 diatomic, so that's why 28, 14 to the 28, you get this mole. If you get mole of nitrogen, so volume will be number of mole into molar volume. Number of mole times molar volume, we get 16.457 dm cube. But here two significant figures 16 dm cube. This is the answer. Okay, come to next. Number 3. This is from organic chemistry. This is an alcohol. 1, 2, 3, 4. 4 carbon containing alcohol, you know. This is the butanol. Butanol. And complete combustion alcohol, carbon dioxide and water, liquid be water. Incomplete combustion water and gas C will be carbon monoxide. You know, in complete combustion carbon monoxide is produced. Acidified potassium manganate 7, this means oxidizing agent. So butanol will be oxidized to organic liquid butanoic acid, carboxylic acid. Then butanol heat with ethanoic acid. You know, ethanoic acid is a acid. Acid reacts with alcohol to produce ester and water. So liquid B will be water and organic liquid will be ester. Now see the answer. A, B, C are different compounds. A is a carbon dioxide, B water, C carbon monoxide. Incomplete combustion. Name the and draw the structure of D. D is a butanoic acid and butanoic acid. 4 carbon. 1, 2, 3, 4. 4 carbon containing carboxylic acid is butanoic acid. Now see, name and draw the structure of E. E is a ester. Name butyl ethanoate. This is the acid part, this is alcohol part. Alcohol. And this is acid. For ester naming, at first you have to tell alcohol part, then acid part. So 4 carbon butyl, 2 carbon alkanoate ethanoate. You see, organic liquid ethanoic acid is the CH3 COOH. It will lost hydrogen, so acid part will be ethanoate. This will lost hydroxide. Alcohol part is butyl. 1, 2, 3, 4. C4H9 butyl. That's why name will be butyl ethanoate. Star E. Now this 4 number question. Particle sum given and their proton number and nucleon number. You know, nucleon number means mass number. Nucleon number means mass number. So number A, state the number of neutron. Here nucleon number, mass number 35, proton number 17, 35 minus 17, you will get Newton number, because mass number equal number of proton plus number of Newton. So number of Newton will be mass number minus proton number. B. State the number of electrons in chloride ion. Here 17 proton number 17 means number of electron will be 17, but here negative 1, that means 1 electron has more, 1 electron extra. So 17 plus 1, electron number will be 18. Number C, potassium is a full symbol for one isotope of potassium. Suggest the full symbol of the other isotope of potassium. Proton number same, mass number different. So this 39, one mass number is more, 40. Describe how the potassium ion is formed from potassium atom. You know, any atom lose electron, loss electron to form positive ion. Potassium minus means lose electron to form K plus, this electron K plus. So how potassium ion is produced from potassium element? By lose one electron, by losing one electron. Potassium chloride is an ionic compound. You know, metal and non-metal forms ionic compound. Potassium chloride has melting point and high boiling point. You know, ionic compound has high melting point and boiling point. Number 1, explain why potassium chloride has high melting point. Potassium chloride has lattice structure. There are strong attraction between positive ion and negative ion. Or you can write potassium chloride is an ionic compound or ionic lattice. There is a strong attraction between potassium ion and chloride ion. So a lot of energy is needed to break this attraction. Predict two other physical properties of potassium chloride. You know, ionic compound dissolve in water, so you can write dissolves in water. And you know, ionic compound conduct electricity in molten state, so conduct electricity as a molten state or in a molten state. Or you can write does not conduct electricity in solid state. Ionic compound does not conduct electricity in solid state. You can write that also. Come to next question. Number 5. This is from chemical equilibrium. This is a reversible reaction and the forward reaction is exothermic reaction, mean delta H value will be negative. This is reversible reaction, reversible sign. So now question is asking you, predict what happens to the amount of hydrogen, this hydrogen in the mixture if the temperature is increased. Mainly this temperature is increased. So this is exothermic reaction. If you increase temperature, equilibrium will try to decrease temperature. So it will go right to left. If position of equilibrium moves from right to left, hydrogen will be decreases. So prediction will be amount of hydrogen decreases. Amount of hydrogen decreases. This explanation, equilibrium shifts or moves to the left to absorb heat, to absorb an energy or to absorb heat. Equilibrium moves to the left to absorb energy. Two, what happens to the amount of hydrogen equilibrium if here important pressure is increased? You know, if you increase pressure, equilibrium will move to the lower number of moles to reduce the pressure. Now you count how many mole gaseous mole present on left hand side and how many gaseous mole are right hand side. Here solid, so you don't count. Pressure is only applicable for gaseous substance, gaseous moles. Here 4 mole left hand side, this solid, this 4 mole. I mean there are same number of moles on both sides, left hand side and right hand side, gaseous moles are same, equal. Prediction stays the same. That means amount of hydrogen will remain same because there are same number of moles of gas on both sides of equation. There are same number of gaseous moles on both sides. Now iron reacts with dilute sulfuric acid to make iron 2 sulfate. You construct the ionic equation, show the ionic equation with state symbols for this reaction. Iron solid, sulfuric acid will form hydrogen ion plus sulfate ion. Iron 2 sulfate from iron 2 ion and sulfate ion. So both sides sulfate ion common, spectator ion, hydrogen gas. Iron solid 2 S plus ion aqueous, iron 2 ion is aqueous, hydrogen is gas. This is the ionic equation when iron reacts with sulfuric acid. Now to describe a chemical test to confirm that iron 2 sulfate is formed instead of iron 3 sulfate. This is the test for iron 2 ion and iron 3 ion. Iron 2 ion, iron 3 ion. Sodium hydroxide solution is added. Sodium hydroxide solution is added. This is the test for iron 2 ion and iron 3 ion. Iron 2 sulfate gives a green precipitate. So you can confirm that iron 2 sulfate is formed. If iron 3 ion present, a red brown precipitate will be formed. Next, the aqueous iron 2 sulfate is crystallized to make hydrated iron 2 sulfate. Hydrated means with water, FeSO4 plus dot 7H2O, 7 mole water. Give the relative molecular mass. This is the 278. you will add all relative atomic masses of all atom. Iron 56 plus sulfur 32 plus oxygen 16 times 4 plus 7 mole water, 7 into 7 times water 18, you will get 278. Then a student uses 2.8 gram of iron to make 12.5 gram of hydrated iron to sulfate crystals. This is the 90% yield. Calculate the mass of hydrated iron to sulfate crystals made from 2.85 gram of iron if the yield is 100%. So 2.8 mass moles of iron, mass in gram divided by molar mass of iron, you get this mole. Moles of iron and moles of hydrated iron to sulfate will be same, so mass will be number of mole into molecular mass. 100% yield, that's why 13.9 gram. Next, aqueous iron to sulfate is electrolyzed using graphite electrode. Predict the product as aqueous, so at the cathode hydrogen, when aqueous solution, hydrogen ion at the cathode, hydrogen ion are reduced to form hydrogen gas, and at the anode, as like sulfuric acid, hydroxide ion are oxidized aqueous, hydroxide oxidized to produce oxygen and water. Oxygen and water. So as at the cathode, answer will be hydrogen, at the anode answer will be oxygen. Now iron is extracted from iron ore in a blast furnace. Describe the essential reaction involved in the extraction of iron. This is from extraction of iron, First, carbon reacts with oxygen to form carbon dioxide. This is the first reaction. Carbon is oxidized to form carbon dioxide. Then carbon dioxide reacts with carbon to make carbon monoxide. First, carbon reacts with oxygen to produce carbon dioxide. Then carbon dioxide is reduced by carbon to produce carbon monoxide CO. Then iron 3 oxide reacts with carbon monoxide to produce iron. First carbon is oxidized by oxygen to form carbon dioxide. Then carbon dioxide reacts with carbon to form carbon monoxide. Carbon monoxide reduces iron 3 oxide to produce molten iron. This is the main reaction. Number C, 6 question. A. Describe how nitrogen monoxide is formed in car engine. Nitrogen monoxide, nitrogen and oxygen reacts to form nitrogen monoxide. Nitrogen and oxygen reacts together to form nitrogen monoxide. Number B, carbon monoxide, this is the carbon monoxide, reacts with nitrogen monoxide to form carbon dioxide and hydrogen. This reaction is extremely slow at room temperature but is much faster in the presence of a catalyst in a catalytic converter. A. Explain why this reaction involves both oxidation and reduction. You see, carbon monoxide goes to carbon dioxide, so carbon monoxide gain oxygen, it is oxidation, and nitrogen monoxide goes to nitrogen monoxide lose oxygen, so nitrogen monoxide lose oxygen, so it is reduced. Here carbon monoxide is oxidized as it gain oxygen, nitrogen monoxide is reduced as is lose oxygen. Now the reaction between carbon monoxide and nitrogen monoxide is exothermic, heat is produced. Explain using ideas about bond breaking and bond forming why this is an exothermic reaction. You know, bond making produces an energy, and in products bonds are formed, and in reactants bonds are break. For bond breaking, energy is needed. For bond forming, energy is produced. Here more energy is released, more energy is produced than absorbed than needed. More in this reaction more energy is produced than needed. Produced more, required less, so extra energy is released. That's why this is a exothermic reaction. Explain using ideas about particles why increasing the temperature increases the rate of reaction between carbon monoxide and monoxide and nitrogen monoxide. You know, if you increase temperature, particles have more kinetic energy, so more successful collisions are occurred per unit time. Here I write particles have more kinetic energy, so more successful collisions occur per unit time. That's why reaction rate become faster. For explain why a catalyst increases the rate of reaction between carbon monoxide and nitrogen monoxide. You know, catalyst lowers the activation energy, so more molecules can react. Catalyst lowers the activation energy. This is the 1 marks, you will get marks. 5. Explain using ideas about particles why the catalyst in a catalytic converter needs to have large surface area. So if catalyst have large surface area, so more exposed particles, more molecules are able to react, so more collision occur per unit time. More, if has more surface area, more particles, more molecules are exposed, so more collision occurs per unit time. Okay, come to next. Aluminum is an element in group 3 of the periodic table. Aluminum is used to make containers of food because it does not react with water. State and explain in terms of its properties one other large scale use of aluminum. Large scale use aircraft because it has low density. Aluminum is used in aircraft because it has low density. B. Explain why aluminum does not react with cold water. Aluminum forms an oxide layer. Aluminum reacts with air, oxygen, Al2O3, aluminum oxide layer, it is more strong. So aluminum forms an oxide layer. This layer is impermeable to water. For this layer, water cannot react with aluminum. The layer is impermeable to water. This layer does not allow water. Describe with the aid of label diagram. With the label diagram, the metallic bonding in solid aluminum. This is the metallic bonding. You know, metal lose electron to form positive ion, plus all are positive ions, and this is delocalized electrons, mobile electrons, they can move. So as bonding, I write here there is a strong attraction between electrons and positive ions, or you can write there is a strong attraction between aluminum ions and electrons. Number D. Aluminum is manufactured by the electrolysis of aluminum oxide dissolved in molten cryolite. Write the ionic equation for the reaction at the cathode and at the anode. Ionic reaction. You know, at the cathode, you know, Al3 plus aluminum ion gains 3 electron to form molten aluminum. At the cathode, reduction reaction occur, and at the anode, oxide ion lose 4 electron to produce oxygen. At cathode, reduction reaction occur, at anode, oxidation reaction occur. Next, calculations. Here a sample of 2.34 gram of aluminum, this is reacted with 50 centimeter cube 0.2 mole per dm cube sulfuric acid. Aluminum mass is given and sulfuric acid volume and concentration is given. Also equation given. Aluminium reacts with sulfuric acid to produce aluminium sulfate and hydrogen. Show by calculation that the aluminium is in excess in this reaction. Here aluminium is in excess, you will have to show. First of all, moles of aluminium mass divided by molar mass. We get this mole. Then sulfuric acid concentration to volume 50 centimeter cube divided by 1000. You have to convert it to dm cube. This is the 0.1 mole. This given. But you see, this mole of aluminium would react with 3 by 2 times of sulfuric acid. Ratio 2:3. So moles of sulfuric acid react would be 3 by 2 of moles of aluminium. 0.0867 moles of Al would need 3 by 2 times of this. This moles of aluminium will be needed. This mole of aluminium would need sulfuric acid how much? 3 by 2 divided by this times. This means 0.13 moles of sulfuric acid is needed. For this mole of aluminium, 0.13 moles of sulfuric acid is needed. But sulfuric acid has only 0.1. Sulfuric acid need more, have less. That means sulfuric acid is a limiting factor. Here aluminium is in excess. So by calculation that the aluminium is in excess in this reaction. So in this reaction, sulfuric acid, more sulfuric acid mole is needed compared to 0.1. That's why sulfuric acid is a limiting reagent and aluminium is in excess. Next, this is from organic chemistry. Alkenes are homologous series of unsaturated hydrocarbon. Name the alkene which has only 3 carbon atoms in its molecule. Alkene. So you know propene, 2 carbon ethene, 3 carbon propene, 4 carbon butene. Draw the structure of unbranched and of branched alkenes. Show all the atoms. All the atoms means displayed formula. This is the unbranched. 1, 2, 3. This is unbranched alkenes. There is no branch, but here branched alkenes 1, 2, 3. Number 2 carbon contains a branch, methyl branch. So this name will be 2-methyl propene. This is a branched alkene. This alkene has a branched alkene. Now see, describe a chemical test that distinguish an alkene and alkane. Chemical test is common test. You know, alkane and alkene, saturated and unsaturated test. Simply bromine water is added or aqueous bromine is added. Result with alkene decolorizes. Bromine water decolorizes or bromine water goes to orange to colorless. result with alkane does not change color, or bromine water color remain orange, remain same. D. Alkenes are manufactured by the cracking of long chain hydrocarbons. By the cracking of hydrocarbon, this equation is given. This long hydrocarbon, this octane, give two reasons why the cracking of long hydrocarbons is important. This is from importance for cracking. You know, longer hydrocarbon are less useful, not useful, but shorter alkane, shorter chain hydrocarbons are more useful. Say ethene is used to make polythene and alcohol, and number 2, provides a source for more gasoline, and is used to make polymers. Say ethene is used to make polythene. You can write any two, I write here 3. Compound X contains 85.7% carbon by mass. So, compound X contains 85.7% carbon by mass and 14.3% by hydrogen. So, you have to calculate empirical formula X. First carbon, hydrogen, their percentage given. After that, divided by their AR, relative atomic mass, you get 7.14, 14.1, 14.3. Then you divide by the smallest one, 7.14 divided by 7.14, you get 1, this is 2. That means 1 carbon, 2 hydrogen. Empirical formula will be CH2. So molecular formula will be C3H6. How C3H6? This from beginning of the question. Here this octane, so X will be 2, 6 carbon, C3H6, then this 14 carbon, 8, 3 to the 6, 14 carbon, hydrogen 30, 18, 16 to the 12, 12 plus 18, this 30 hydrogen. That means formula will be, molecular formula will be propene. Here propene, from this to this has come. Now next, ammonia is used to make nitrogen fertilizers. Ammonia is manufactured using the reversible reaction between nitrogen and hydrogen. You know, construct the equation for this reversible reaction. Nitrogen reacts with hydrogen to produce ammonia. This is the manufacture of ammonia by Haber process. 1 mole nitrogen reacts with 3 mole hydrogen to produce 2 mole ammonia. Number B, ammonia is used to make soluble salt ammonium nitrate. Name the acid that reacts with ammonia to make ammonium nitrate. So ammonia reacts with nitric acid, ammonium nitrate fertilizer will be produced. That's why the acid name will be nitric acid. Ammonia reacts with nitric acid to produce ammonium nitrate. Calculate the percentage by mass of nitrogen in ammonium nitrate. First, relative molar mass of ammonium nitrate is 80. How? 2 nitrogen here, 28, 14 to the 28 plus 4 hydrogen plus oxygen 3, 16 times 3, 16 times 3 you will get 80. So percentage of nitrogen will be, in total 80 there are 2 nitrogen, I mean 28, 14 to the 28. So 14 times 2, 28, 28 by 80 into 100, 35% of nitrogen present in ammonium nitrate. And then see, nitrogenous fertilizers ammonium nitrate leaches from the farmed and causes water pollution problems in the rivers and lakes. Name the process caused by the type of water pollution. This process is known as eutrophication. And number 2, explain why this type of water pollution problem is increased when nitrate fertilizers are used instead of other fertilizers, because nitrate fertilizers are more soluble. That's why these problems happen compared to using other fertilizers. Nitrate fertilizers are more soluble than other fertilizers. A farmer adds ammonium nitrate in soil. The farmer then adds calcium hydroxide, is alkali, the same soil. State the purpose of adding calcium hydroxide in the soil. Calcium hydroxide is a alkali, so it is used to reduce the soil acidity. To reduce the acidity of soil, calcium hydroxide has been used up. To construct the equation for the reaction between ammonium nitrate and calcium hydroxide. You know, any ammonium compound reacts with alkali to produce salt plus ammonia plus water. Any ammonium compound, ammonium salt, reacts with alkali to produce salt plus ammonia plus water, 3 products. Now you see salt, calcium nitrate, ammonium ion breakdown to form ammonia gas plus water. So using this equation, explain why the ammonium nitrate fertilizers is less effective after calcium hydroxide is added. So as calcium hydroxide is added, calcium hydroxide reacts with ammonium salt, it produces one gas, ammonia. This ammonia, as it is gas, so it's lost easily. That's why I write ammonia is lost. This is the answer. Okay, thank you dear students. Please subscribe, like and share my channel with your friends. Thank you.